Welcome to problem of the day 130. This is the Bernoulli equation, so I'm going to be explaining it. So it's a little bit different today. This is an energy equation for fluids, I believe Newtonian fluids. And the first term we start with is P1 and P2. These are both static pressure at a point in the fluid cross section. So you'd look at point 1, and that's P1. Look at point 2, that's P2. And that goes for all the rest of the terms. Looking at points at a given cross section. Rho is the density of the fluid that is in your system. V is your mean velocity of a fluid in your system. Again, at a different point is the difference between V1 and V2. And then G is the acceleration due to gravity. And then H is the elevation of water at a given cross section. It can sometimes be denoted as Z. And then obviously rho times G is also the unit weight of your fluid. So if you didn't have the density here for that term for whatever reason, you could use the unit weight, and then you could solve for the unit weight, or solve for rho with the unit weight as well. And then with this, we can kind of think of each term as a separate form of energy per se. So we got pressure, which is pressure head, basically like the actual pressure in, sometimes it can be atmospheric pressure or just the pressure applied in general. And then you got kinetic energy, which is the velocity head. So this is due to the stream or fluid in the pipe actually moving. And then potential energy again, but it's an elevation head, or sometimes just called head, and that's due to the difference in height between one cross section and the other cross section. So if it goes down or up, that's a change in elevation, so you'll have a change in energy, and obviously it will change to be added or subtracted relative to that datum. So we'll go over this in future videos of the Bernoulli equation and do some problems. So I hope this explanation helps you understand the basics of the equation.